Priority plays a very important role with HSRP. We have a default priority of 100 for every single router within that group. So if we don't change the priority, who becomes the active forwarder? Higher is better with HSRP. If they're all 100, then the tiebreaker is via the IP addresses of the interfaces participating in the HSRP group. So if we have one router that's using the IP address of 10.1.1.1 and another one using the IP address of 10.1.1.2, then which router becomes the active forwarder? Well, since priority is tied at 100 by default, the one with the IP address of 10.1.1.2 configured on its interface becomes the active forwarder. However, if we want to control HSRP and the active forwarder, then we can identify a higher priority on the device we want to be that active forwarder. And if we make a mistake on the priority or we configure the wrong priority on the wrong device, then we could end up with the wrong device being the active forwarder as well. Let's examine that. In this case, DSW2 is currently the active forwarder. And if we go to DSW2 and type in show standby brief, we'll see from this output that active equals local. If we use the command show standby, we'll see it says right here, state is active. But we don't want DSW2 to be the active forwarder. We want DSW1 to be the active forwarder. If we perform a trace from our client, we'll also see that the active forwarder is DSW2 based on the first hop IP address of 10.1.1.2. So let's confirm that right here. There we go, 10.1.1.2. So we've confirmed in many different ways that DSW2 is the active forwarder. It even says right here, active router is local. So remember, to be the active forwarder, you need the higher priority, and you're going to need preemption enabled to make sure that you will always be the active forwarder. But this is not what we want in this scenario. We want DSW1 to be the active forwarder. And if you analyze right here, it says the standby router is 10.1.1.1. Its priority is 110. Oh, there we go. I think we found our issue. DSW1 has a lower priority than DSW2. DSW2 currently has a priority of 111, so 111. So let's go back to DSW1 and verify. Show run interface VLAN 10. There's our priority 110. So either this priority was configured too low or DSW2 was changed when it shouldn't have been. And I'm going with the fact that DSW2 is changed when it shouldn't have been. So let's just go back to DSW2 and let's type in configure terminal interface VLAN 10 and we'll say no standby 10 priority 111. This will drop our priority back down to 100, the default. As you can see, we went to the speak state on DSW2 and then the standby state. Why? Because we would have received a hello packet from DSW1 and that hello packet showed that DSW1 had a higher priority and it had preemption enabled. If we go back to DSW1, we'll see we are now the active forwarder for group 10. We'll type in show standby brief. We can confirm it there as well. Active is local. Also says here state is active. Preemption is enabled. Now, if preemption hadn't been enabled, we would not have taken over the active forwarding role, even though we had the higher priority. So preemption has to be enabled, and we have to have the higher priority to take over the active forwarding role. And again, if you want to verify that on your PC, you can do your trace. And in this case now, the first hop should be the IP address of 10.1.1.1 of DSW1. Notice how it is not the virtual IP address that is being returned in our traces. And that's really important from a troubleshooting standpoint. The virtual IP address is 10.1.1.62. The trace is telling us the the IP addresses of the router interfaces. That's what it's telling us, and that's great. I love that output because it allows us to verify, yes, we are using DSW1, or yes, we are using DSW2. If it was returning the virtual IP, then I wouldn't be able to know exactly who was being the active forwarder.